Hello. So, in this example, we are going to be taking a derivative using the definition of a derivative, but instead of doing it at a point, what we're really going to try to do is do it as a function, meaning that we want to leave the x in there as a generic variable so that when we get to the end, we can just plug in an x to get different values. Okay. So right off the bat, first thing I'm going to do is remember or recall my function definition for the derivative, right? So that's the limit as, let's use delta x this time, going to 0. And then I have this f of x plus delta x minus f of x all over what would normally be x plus delta x minus x, but that's just delta x, right? So this is my definition just generally, right, for a derivative. But now I have my f of x, right, that 3x plus 19. So I'm going to just plug in my values, right? So I'm going to get the limit as delta x goes to 0. So I'm going to have f of x plus delta x, which, right, with my f of x up here, that's going to be 3 times the input plus 19 minus, now just f of x, that's going to be the 3, so to be clear, 3x plus 19 all over that delta x. Right? So to be clear, this is that first f of x plus delta x, so I plug the x plus delta x in wherever there's an x in my original definition, and then just the x1, which is just the original definition, and then my delta x. So now I can distribute my negative. Remember, I want to keep writing my limit the whole way. So I'm going to distribute my 3 here. So I'm going to get 3x plus 3 times delta x plus 19 minus 3x minus 19 all over delta x. And that is still the limit as delta x goes to 0. So here I have a plus 3x and a minus 3x. I have a plus 19 and a minus 19. So these, right, those cancel, leaving me with just 3 delta x over delta x, which is then the limit as delta x going to 0 still. But here my delta x's cancel, so I just have 3. Right, so again, to be clear, here my delta x cancels. And now the limit as delta x goes to 0 of just 3 is 3. All right. So pretty straightforward. And this sort of shouldn't be all that surprising, right? Because if we look at the original function up here, 3x plus 19, that's a line. So trying to find the slope at any given x point, well, the slopes are all the same. That's how a line works, right? And the slope is that m, right? The 3 in front of the x. So that's exactly what I got, okay? So that's that. Hello. So for this example, we are going to compute a derivative, and we're using the definition of derivative, and moreover, we want to do this sort of as a function, right? Leaving it as a generic x. Now, there's a couple ways we could go about this because this thing is in factored form. And factored form is typically a very nice form to use, but when it comes to computing the derivative, having it factored is sort of going to make our life a little harder. So I could leave it as is and just go straight into the sort of definition, the limit definition of a derivative, but instead, the first step I'm going to do is to actually expand this out. So my f of x then, so it's the 3x minus 1 times x plus 5, so I'm just going to expand that out by doing FOIL, right? So I'm going to get 3x squared, that's the 3x times x, I guess plus 15x, that's the 3x times 5, minus x minus 3, which if I clean this up, is just going to be 3x squared plus 14x minus 3. Okay? All right. Now I'm going to remember and use my limit definition. So that's the, in fact, I do this. So I'm going to have the limit definition just in general. So I can do this with, let's do dx this time. Dx going to 0 of, so this is the f of x plus dx minus f of x all over dx. So remember, there's sort of a number of notations that are used depending on the discipline. Sometimes it's delta x, sometimes it's dx, sometimes you might see like h or some other letter. So I'm trying to sort of use the different notations just so you've seen them at least. But it's all sort of what symbol you choose to make that, right, the dummy point that's sort of merging in, right, that distance to that second point for the secant line that squishes in. So really, I mean, you could call it smiley face if you really wanted to, as long as you were sort of consistent, it would work. All right, so now I'm going to apply this definition to my function up here, right? So in particular, I'm still going to keep my limit as dx goes to 0. So here I'm having f of x plus dx, so I'm going to plug that in everywhere where I see x. So I have 3 times x plus dx squared plus 14 times x plus dx minus 3, right? So you don't need the brackets, but I'm going to put them here just so you can see. This here is the f of x plus dx, right? Then I have to subtract f of x, but that's just this thing right here. So here you definitely want parentheses, so you remember to expand the negative. So this is 3x squared plus 14x minus 3. And all of this is over dx. All right, now's the fun. So now I'm going to distribute everything, which means I need to distribute the negative sign, I need to distribute the 14, and I need to FOIL out this thing here, this square, okay? So still dx going to 0. I'm not going to distribute the 3 yet because I don't want to do like everything all at once here. So I'm going to expand this out. This is a perfect square. Sorry, this is a sum squared. So that's going to be x squared plus 2 times x times dx plus dx squared. So that's this piece just written out. I haven't done anything with the 3 yet. Plus, so I'm going to distribute the 14. So plus 14x plus 14 dx minus 3. That's there. Then minus 3x squared minus 14x minus minus 3. Okay. So often at this point, some stuff will cancel. So I'm just going to make a note of that. So for example, I have, let's see, minus 3 and plus 3. So those cancel. I have a minus 14 and a plus 14. So those cancel. I have a minus 3x squared, which will cancel with that, but maybe I'll do that in the next step. So let me write out the next step. Keeping my limit. All right, don't want to forget that. It's easy to forget. Oh, speaking of forgetting things, all of this over dx, right? There we go. I was like, there should have been a fraction, and there wasn't a fraction. All right, so now I'm going to distribute my 3. So I have 3x squared plus 6x dx plus 3 dx squared. So that canceled, I still have a plus 14 dx. I still have a minus 3x squared all over dx. Now I can see, right, this minus 3x squared indeed cancels that 3x squared. Continue on. So I have now the limit as dx goes to 0. So I'm left with a 6x dx, a 3dx squared, and a 14dx. So I'm going to see, right, that there's a dx in each of these. So I'm going to pull out the dx, and that leaves me with 6x there, plus 3, there was dx squared, and I pulled out one of them, so I'm going to get plus 3 dx. And this dx I pulled out, so this is going to be plus 14 all over dx. And again here, right, this dx cancels against that one because that's now multiplying everything, right? Because I can't cancel the bottom unless I've sort of gotten it so that it's multiplying everything in the top, right? I have to make sure this multiplies everything before I can cancel. So this then, still with my limit tagging along for the ride. So I now have 6x plus, I'm just going to rearrange this slightly. So this is plus 14 plus 3dx. But now, right, I don't have the dx in the bottom, so now I can actually evaluate, right? Because the whole thing is trying to get rid of the 0 in the bottom when you try to plug in, right? So now I can plug it in and evaluate. If I plug in 0, well, I'm going to get 3 times 0, that's going to go away, but these are going to stay exactly the same. So I'm going to get 6x plus 14. And this is indeed my, there we go. This is my answer, right? So this is the derivative of my function at some generic point x, which again was my goal, okay? So there we go, that's that. Hello. So for this problem, we have a f of x. We want to compute the derivative, but we want to compute it as a function, right? So the idea here is that we want to leave the x in as a generic thing. So again, I'm going to start with just sort of recalling that limit definition. So remember, we want the limit. Let's do h this time, as h goes to 0 of f of x plus h minus f of x all over h, right? So that's what I'm going to do. I'm going to start by just sort of plugging in what I have for my f. So I'm going to get the limit as h goes to 0. So again, right, I have the x plus h that gets plugged in wherever I see an x. So I have the 1x here. So I'm going to have the square root of x plus h, can't go wrong with adding more parentheses, minus 3 plus 9. And again, these brackets aren't necessary, but I'm doing it to show you where the f of x plus h went. Then minus, and these very much are necessary because I want to make sure to distribute my negative correctly. So now I want just my f of x, right? So I'm going to have the square root of x, minus 3 plus 9 all over h. Okay, so now same deal. I'm going to expand whatever I can. Not much I can do with this, not much I can do with that, but I can expand the negative. So I'm going to have the limit as h goes to 0 of square root of x plus h minus 3 plus 9 minus square root of x minus 3 minus 9 all over h. And there's a little bit that I can do here, right? So I can, for example, cancel out, right, the 9s. But that's really all I can do. Okay, so such is life. Keep going. Limit as h goes to 0, square root of x plus h minus 3 minus square root of x minus 3 all over h. Now the next step is a little tricky because these roots are really in the way, and there's not really anything I can do at this point in terms of like trying to be clever to get h out of there, out of the bottom. So what I'm going to do is try to rationalize, right? So you've probably sort of used to or have seen rationalizing the denominator. We're going to be rationalizing the numerator, meaning that I'm going to multiply by the same thing, the same thing in the top, only I'm going to switch the sign. So instead of a minus, I'm going to have a plus. And I'm going to do that in the top and bottom. So in particular, in fact, I'll do this in a different color so it's clear what's happening, or clearer, hopefully. X plus h minus 3, so that's the same first term. Now I'm doing plus square root of x minus 3 on the top and bottom. So x plus h minus 3 plus square root of x minus 3. And the idea here is that I've made a factored version of the difference of squares, meaning when I FOIL this out, I'm just going to get the first thing squared and the second thing squared, so I'm going to be lifting those roots. And the bottom is just going to be a mess, basically. But it is what it is. We're going to have to live with it. So I'm going to have the limit as h goes to 0 still of, so I'm going to have the first thing squared, which basically lifts the parentheses here. So I'm going to have x plus h minus 3 minus, same deal with the second one, x minus 3 all over, and now I'm going to have h times this whole mess, square root of x plus h minus 3 plus square root of x minus 3. But now I can, again, sort of expand, which in my case means I'm going to be expanding this negative. So I'm going to have x plus h minus 3 minus x plus 3 all over, right? So that was distributing the negative. Bottom stays the same. But now again, after sort of expanding these out, I'm going to notice the plus 3 and the minus 3 cancel, and the minus x and the plus x cancel. So this gets me to the limit as h goes to 0. Only thing in the top is h times square root of x plus h minus 3, square root of x minus 3. Now, since the only thing in the top is h is multiplying all the stuff in the top, right? So I'm going to get that and that are going to cancel. And this is good news, right? Because this means that h is now canceled out of the bottom. So it is hopefully going to be the case that when I try to plug in 0 for h, I'm going to get something that is hopefully defined, right? It's not going to have a 0 somewhere. Now, this might be a little shifty seeming because we still have this thing. And if you remember in the beginning, this thing was 0 when we plugged in h as 0, we would get 0 here. But the sign difference is what's going to actually save us. So let's see what happens. So first, I'm just going to rewrite this as the sort of simplified form. So again, h still going to 0. I have 1 over square root of x plus h minus 3 plus square root of x minus 3. And now when I plug in h is 0, I'm going to get a 0 here, and there's no other h's, so I'm going to get x minus 3 and x minus 3, but they're added, not subtracted, so I'm not going to get 0. This is good news. So I'm going to end up with 1 over square root of x minus 3 plus square root of x minus 3, which is really just 1 over 2 times the square root of x minus 3. Okay? And that's my answer. So this here is my function version of the derivative, right? So I plugged it into my derivative form up here. That got me sort of this mess, which I expanded out the negative so I could cancel a little bit, but eventually I got to a point where I had a bunch of square roots that I couldn't get rid of. So rationalized, right? So in this case, I rationalized the numerator, which let me sort of lift those roots, which let me expand, right, that negative out again, which canceled a ton of stuff. And that's really, everything sort of worked out from there. So that was really the key, is thinking about this rationalizing. Okay. So that is that.